Hey guys, it has been a while, so I thought it's about time that I return to the competitive programming community. And what better way to do it than I don't have the page up. Then Codeforces Blitz Cup 2026. So I've got to be really quick because I'm about to start. But this is a knockout elimination tournament, basically, where I'm facing an IGM in round one. So for some reason it's not on here, but here it is. Okay. Yeah, should be ready. Yeah, let's get right into it. Okay. Uh, should be beginning soon. Okay. We're in. There are people. They stop participating in X-Men intervals. This means the first participant starts at 0, second at X, third at 2X, and so on. Satisfaction of all participants. The number of people, and then NX. Wait, the number of participants that have started but not yet finished. So for each one, it's just the number that. Oh wait, this is really small. Shit. Okay. We have N, X, and T. Yeah. Just go through them all in like 2 pointers. And then, that's it. Oh shoot. Okay, I misread that. The values themselves can be pretty big. I see. Okay, so we've got to work this out. Let me do this real quick. So the first one starts at time 0. So I basically got to T over X and then round down. That's for most of them, but then for the ones at the end, you just decrease by 1, right? So let me look at an example real quick. 2 and 5. So if it's 5 and 2, I'm just doing this off by one thing. If I've got 2 and 5, wait, which one's 2? 2 is X. 2 and 5. I'll have 2 after me that I'm in contact with. So it's 5 over 2, rounded down, should be. If it was 4, it would still be, this isn't very precise. Or starting it now, but haven't finished yet. Okay, that counts. So even 4 counts. But if it was 3, then it would be 1. So it's just division rounded down, and then we add them up, right? So the answer is P over X rounded down for each one, but then the last ones are smaller. So we need to sum the numbers from 1 to max. And then add rent times max. I should have. I'm just going to submit and then test it. I should have opened the problem. Row. I should have opened the problem. Wrong answer on test 2. Or it's correct on test 1, seriously? Okay, something's up. Long. Resubmit. Okay. We got A. That might be the only points I get. We'll see. But yeah, I didn't have time to explain the format of this contest, really. But you can basically see what's going on, right? We only have one problem. And we both trying to solve it, and then the problems get harder progressively, and they're worth more points. So yeah, we have 30 more seconds before problem B shows up. Okay. Alright, it's kind of intense. What? Okay. Build the permutation. Tell me if there is a permutation of integers from 1 to n such that there are exactly a integers, there are a positions that are local maxima and b local minima. Find any such permutation. Okay. A local maxima and b local minima, right? So, I mean, the sum must be at most n, and then if we have, it's a constructive, very nice. Okay, a local maxima. So, I mean, local maxima can't be next to each other and local minima can't be next to each other, but other than that, it's fine, right? So, and we want exactly a local minima, and they have to be in the middle. So, obviously, like, we can't have anything in the ends. And if we have 2 local maxima, then something in between them must be a local minimum. So we can't just have like local maxima on their own. Like we can't have 2 local maxima next to each other, obviously, and then we can't have them one apart either without a local minimum in between. So we can have like blocks of max, min, max, min, max, and then at the end of that, we have to construct it. We have to construct it. At the end of that, we have to print. And in between those blocks, we can have like something that isn't a local maximum. This is hyper confusing, actually. So the points at the end we can do whatever with, and then we could like alternate in between. Let's say, but what if we want just lots of maxima and no minima? I don't think we can do that because we need the maxima to be at least 2 apart if we want no minima. Oh, we can't have no minima, right? Like we need to have minima in between maxima. So it's like a maximum. If you have the next maximum at some point later and it's a local maximum, then you've got to have a local minimum at some point because you have to start going down and then you have to start going back up. So you just have to have like maximum, minimum, maximum, minimum. You can put anything you want at the end. We might as well just put it at the end. So maximum, the first like local maxima or minimum has to be at some point, and the last one has to be at some point, and then in between it just has to alternate. So I think these guys need to be like 1 apart. These numbers need to be at most 1 apart, and they need to be not too big. I'm pretty sure that's it. And then we need to construct it as well. Okay. I hope that's correct. Given the nature of this speed-based event, I don't really have much time to check. So if that's a bad way of doing it. Or if a plus b, we can't have like, is greater than -2. Then we can't do it. Yeah, in theory, okay. Otherwise you can, and hear me out. Let me see how we're going to do this. So if the numbers are the same, or if one of them's bigger, so if a is greater than or equal to b, that means, wait, a is maxima, right? A is maxima. If a is greater than or equal to b, then we do maximum first. That means we want min, we want something small, and then big, small, big, small, big, small. And then as soon as we stop needing values, we need the last one to be on the correct side, and then everything else to just keep going that way to stop it being a local guy. So what are we doing here? Oh man, if we have 1 point and then 2, 3. So A is greater than equal to B. Okay, let me do this. If A is if B is greater than A, swap equals true, swap AB, and then at the end, it's swapped. We're going to go through it and reverse it. Right. So now we only need to deal with the case where the number of maxima is either equal or, right. So now if it's equal, then we need to start up, down, and then we need to go just up, right? So the tail is up, and then otherwise it's up, down, up, and then down, down. So we have these two cases basically. If they're equal, then we need the top next big equals n minus a plus 1. Next small equals n minus a, right? Down, up, down. Okay, so I need to put next small, and then next small, big, right? So if they're 3 each, small, big gives you 1. Small, big, small, big. 1, 2, 3. And wait, what does that give you? That only gives you 2. 2 local maximum, 2 local minimum. Okay, so I need to do it a plus 1 times. Wait, how many bigs do I need then? Oh, this is for the other one. This is for the other case. Here, actually, the number of smalls I need is a plus 1. P needs to be empty. P push back next small. P push back next big. And then at the end, we're going to do while next. We're going to decrease this. We're going to increase this. While next big is lesser than n. P push back next big plus plus. And then here it's kind of similar, but we're going to go through. So here we want 3 bigs and 2 smalls. 1, 2, 3. 1, 2. Right. Do small, big, small, big, small, big, and then smalls. And so this time we do it 8 times. Wait, I hope I'm being told if someone says. Next small minus minus, right? And then next big plus plus. And then same thing, but this time it's next small greater than 0. P push back next small minus minus. And the initialization has to be I need a small. I need a big ones. So n minus a plus 1. Yeah, that seems right. And again, I'll just do this. For now, I need to print it. That seems like a reasonable thing to do. Okay. 4, 1, 1. 1 big, 1 small. 6, 1, 2. Wait, I should just be submitting this for. This is against my nature, but I'm just submitting. 6, 1, 2, 1 big, 2 small, right? We want 1 big. That worked. No debugging. Okay. Okay, man. Sure. It's kind of intense. All right. Problem C. Problems get more. The problems get harder, and they also get. They're also worth more. So. Yeah. Wait. How long is left in the entire contest? I don't know that. I think it's been like 20 minutes, right? It's been 20 minutes. Oh, he submitted 4 times on B. So yeah. He had bugs. It seems. Okay, good luck. Problem C. I'm just refreshing maniacally. String modification. Uh-oh. Strings. Vasya has a string passive like that. He just has to make the following modification. Pick at HK. For I from 1 to n minus k plus 1, reverse the substring. Sorry, what? From I to I plus. Wait. Okay, so. for example, if this, if the string is this and k is 2, below a series of transformations, the string goes through. K is 2. Wait, for all I? For I from, okay. For basically, you start from the first index and just reverse, like QW, then you reverse QE, then you reverse QR. Okay, so in this case, since it was 2, it just moved Q to the end. Hence, the resulting substring is work. Vassi wants to choose a K such that the string obtained is lexicographically small as possible. Do I need the string or the K? I need both. Okay. I need the lexicographically smallest string achievable with this thing. I just need to figure out where the string is going. So where all the letters end up with a certain K. So I've got A, B, C, D, E, F, G, H, and let's say like K equals 3 or something. So like whichever character, whichever K you choose, let's say you choose like K equals 4, that means the 4th character will end up at the front. So the Kth character will always end up at the front. Because like you swap that and then you just move on to the next index. So you need to choose one of the smallest ones to end up at the front, and then of those, what's the next character? So like index K ends up at position 1. So this is like some permutation. Each K defines some permutation, right? So what ends up at position 2? It's whatever was at position K plus 1 after the first swap. The first swap didn't touch K plus 1, right? So wait a minute. So let's say K is 5, like concrete example here. Let's say K is 5. If I swap the, if I start swapping, so 5 ends up at position 1. It's like 5, 4, 3, 2, 1, 6, 7, 8, so on. And then I swap the next range, and then it becomes 5, 6, 1, 2, 3, 4. And then I swap the next range, and it becomes 5, 6, 7, 4, 3, 2, 1. This is kind of weird. Then I swap the next range, and it becomes 5, 6, 7, 8. 1, 2, 3, 4. Wait. Okay, I'm struggling to like realize why this is happening for a second. So, why is this going on? Is it like the K minus 1 values that are at the front just stay, and they end up at the end? So I need to like treat even K and odd K separately, and then just do something like try it all. This. Okay, so 2 to K, just like, sorry, 1 to K minus 1 on the first flip moves to positions 2 to K, and on the second flip they move to 3 to K plus 1. And then they're always in the range, and then the other index is just the next index after that just keeps coming in. So this basically just takes the first K minus 1 and just moves it down to the end, right? So now 9 will move in, and then 10, and so on. Yeah, and then the last swap brings the last character into like whatever is K minus 1 before that, and then 1 through K minus 1 just stay at the end. So I've got to choose a K so that like, so basically by choosing K, I'm choosing the first K minus 1 characters get moved to the end, and if like K is odd, it's flipped or something, but well, depending on the parity, it'll be flipped. Okay. What do I do with that? Let's assume it's not flipped first. Like, I just need to find the biggest. See, this is what happens when you don't know string algorithms. I just need to find the biggest range across which it gets. It's like, wait, I need to find the lexicographically minimal string. that results from just like dropping the string in half and swapping the halves. So in theory, that's doable with what? That's doable with like binary, suffix, like a suffix database, which I don't know how to implement, and I'm pretty sure we're not allowed boilerplates here, so I've just got to. I mean, I can figure it out, but I'm pretty sure my opponent will know how to do this. So, I mean, the issue is I need to like for odd indices, it needs to be flipped, right? So, how am I doing that? So I need to do this thing twice. And I need to be indexing into the reversed string from the end the other half of the time. That's actually quite, yeah, that's not great. I mean, in theory, I know how this is done, but I don't like it. I don't think I should start doing this yet. Wait, so I've got a string. For all possible start indices. So like for k, for 5, for example, k is 5. I'm saying if k was this, I'm gonna start the string from here, and then I'm gonna take the end of the string, the rest of the string, and put it at the end. And then I need to do exactly the same problem again, but with like the rest of the string when it's being put at the end, it needs to be flipped. The issue with that is the flipped version is because I'm flipping the string, I'm basically just starting from. I don't know if I can do this with like the binary increase method that the string, the suffix array uses. I've also never implemented a suffix array, but that's beyond the issue right now. How do I do this? I need to get the. Am I sure I need this data structure? Okay, apparently I don't. Or wait, no, maybe I do. I don't know. Maybe he's just really fast at implementing this data structure. Did I miss something? Because we literally need like the biggest. Wait, how long is this string? Dude! Jesus. Yeah. Kind of. That's a pretty stupid mistake to make. Not reading the constraints is not a good one, and might cost me. Okay. Oh my god. Okay. I mean, let's stick to it. Obviously. It's just not good. Okay. Yeah. Let's just try them all. The result is substring from k onwards, and then I also need to add the first k minus 1 characters. Wait, k being 1 indexed actually. But then if something if the number of swaps is odd, and what's the number of swaps? If okay, he solved it. Yeah. Oh man, that actually. Read the problem, man. Read the problem. Okay, fair play. 2 squares. You're given 2 squares. One side. Oh God, no, please. Geometry. Okay. One parallel, one perpendicular. One at 45 degrees. Find whether the 2 squares intersect. Dude. They intersect even if they share one common point. Okay. Are these squares of any size as well? Dude, this is just like geometry boilerplate. this is just wait. Oh, specifically, the corners are. So they can also intersect without the corners being inside the respective squares. But it looks like actually either a corner or a center has to be inside a square. I'm actually not good at geometry, so I'm just going to implement that and hope it's correct. Like, this is not how you should do things, but I know that he's going to beat me otherwise, so I'm just going to hope that's correct. Okay. Coordinates of one vertex. Okay. So. Oh, I can't even. Wait, when is a point inside a square when it's tilted? Wait, what order are we in points? Coordinates within each line are either in clockwise or counterclockwise order. Thank you. I appreciate that information. Or lack thereof. What is this? So this is the first. Oh, 4 pairs of integers. Each pair of coordinates represents one vertex. So 0, 0, 6, 0, 6, 6, 0, 6. And this is the other one. Okay. So, I can optimize this further actually because I can rotate the whole picture by 45 degrees before checking the other one. So, how do I represent this? I don't know why I'm using vectors, don't ask. This is interesting. Okay, so hopefully, what's wrong? Okay, that's fine. So now I need to check whether any of I'm just going to append it at the end. Oh, I also need to divide by 4. I guess I just won't divide by 4 and just add them. That's really stupid. I'm going to make these all 5. And I'm going to do x0, 5 plus equals x0, I. Like, I'll just store the sums at the end. That's kind of ugly, but what can I say? I'm in a rush here. And then same thing for this. I should maybe have done this all in like a bigger loop, and the 0 and 1 should have been an index, but hey, you live and you learn. Okay, so now we've got all that. This is not telling me when he's solving it. I don't have time to fix this. So now I just need to check whether all these points are in x0. So I need to check whether or not any of the points in this 1 are inside any of these, basically. Are inside that. And to do that, I'm going to do x min. I'm going to assume it's parallel, basically. So why are these balls? Why are these balloons? Can't type, so I'm going to copy it. Okay, and now I just go through. And there should be 5 points in this. I should check if x1i, if it's within range. And y min is y1i, and y1i is max. Return true. Also, when we reach the last point, we've got this like 4 scaling by 4, so I need to multiply all these by a coefficient, because that's equivalent to dividing the other one by. This is like the ugliest code I've ever written. This is the ugliest code I've ever written, but please allow it. Yeah, so now we also have to check it the other way around. The problem is we can't. So how do we do that? We need to rotate by 45. We need to rotate all the points by 45 degrees. What does that mean? We set 45. Wait, why am I working in integers? This is not going to work. Oh, I need equality. Oh, I should have made these all floats. I should have made these all floats. That's just great. Okay. Now we need like epsilon equality and stuff. Because how am I rotating this? If I've got basically if I've got a point now at 1, 1. Wait, no, I think I can. going to do some kind of a rotation matrix. So anything like this 1 over root 2, 1 over root 2, minus 1 over root 2 stuff. But what if I just multiply the whole thing through by root 2? So I get 1, 1 minus 1, 1. Right, so I need the new coordinates. Contest is over. Bro. Okay, well, we didn't get too far into that. I mean, I guess that's it. None of us solved D. Yeah, I think this would have worked though. This like root 2, like dropping the root 2. I really should have had like the tablet I'm writing on the screen, but I just thought it was too intense. I was getting ready to start with like 2 minutes to go, and I actually delayed the contest. If you were waiting for the stream, you probably noticed that it started a bit later than expected, and that's on me. So I didn't have time to like connect everything up properly. But yeah, so it's over. I guess that means I won. Huh. Damn. Okay. That's unexpected. GG's. Okay, well, I mean, since this is over, I'll just go through the problems once again. Same mistake again. I should have scrolled down. Why am I not scrolling down? But yeah, like in this case, this point is inside the square, basically. So just give me a second. I'll just share my screen, and then I'll actually just explain. The solutions to these problems real quick. That was quite exciting, though. It was quite fun. Okay, here we go. Let me utilize the recent advancements in technology to provide you with an insane split screen setup. Man, okay. Yeah, this is a tablet. It's quite cool. I can scroll on it and stuff. Okay, so I'm gonna walk you back through the problems real quick. I mean, they weren't anything too special, but let's do them regardless. Just conceptually. I mean, you saw me writing code. Ideally, you should have seen me drawing this stuff on the right as well. Even though it's not particularly, they're not the best diagrams visually. in terms of presentation. Okay, so actually maybe I move my face for a bit so that you can actually see the screen fully. Now I'll just swap these in hindsight. There we go. Wait, what? What? This is one part. Yeah. All right, so the first problem looks like this, essentially, what I've drawn here. So there are n people doing a contest. Well, doing contests is a relevant detail. So there are basically like n intervals, each are of length t, and the starts of these intervals are x apart from each other. So like the first one starts at time 0, the second one at time x, and so on. But like the important thing is that they're x apart. So each of these ranges is x, and there are n intervals in total. And you just want to know like how many pairwise overlaps there are, basically, because that's an equivalent version of what this problem is. And so if you think about it, if you just tile like an infinite number of these instead of n of them, you can work out like in the middle of the pack how many each one would be overlapping with, because like, it would be like constant. Like at the end point, obviously they're just like, for this one at the end, it'll be overlapping with fewer ones than this one in the middle. But if you just have an infinite number of them, then they'll all be overlapping with the same number. So like the first step is just to find that number. And that number is basically, so if you take this range, you just want to know like the first range after it that'll start after it ends. And because the first range has length t, and each next range starts x away, these like gaps are size x, so it's just t over x is the distance till the number of ranges that will start after this one, but still be alive in a sense when this one will already be alive when this one finishes. So basically, it's t over x rounded down will be the dissatisfaction in terms of like the problem statement. The dissatisfaction will be t over x rounded down for each participant, except for a few at the end, because like for the last participant, the dissatisfaction is just 0 because nobody has started since the last participant. So yeah, that's just it's just t over x for most of them, and then for the last few, it's 0, 1, 2, 3, and then it goes up until either you run out of like values, so you hit n minus 1, or you hit t over x, and then it's capped at t over x for the rest of them, and you just like do some maths to add those up. I explained that pretty badly, but that's it. Okay, next problem. Yeah, the next problem was the permutation problem. I think I basically explained this sufficiently during the actual stream, but because of the lack of visuals, it was probably quite hard to follow. But so the problem is you have to find whether there's a permutation of length n with exactly a local maxima and b local minima, where a local maximum is just like one that's a value that's strictly bigger than both the values on each side. and the opposite for a local minimum. And so the key idea here is that you realize like you have to figure out what constraints you need for this problem, and you realize that like so I'm going to be drawing, by the way, where horizontally it's the horizontal space is just like indices. So this is like the first value, this is the second value, this is the third value, and then like vertically is how big the value is. So like this is the first value is bigger than the second value, and then the third value is the biggest one. Oh, I've got a nice pointer. Okay. And so yeah, you realize that so the total of A and B have to be at most n minus 2, because like the first and the last value can't be local minima or maxima. And you have to have enough values to actually have A plus B in total. And then other than that, you actually realize that if you have two local maxima, then you have to have a local minimum in between them, because it's for the local maxima they have to have decreasing values on each side. And so at some point you have to stop decreasing and start increasing at least once. So each pair of local maxima have to have at least one local minimum in between, and same for the other way around. So local minima have to have a local maximum in between. So that just means like you have to have these in alternating fashion. And so the difference between A and B has to be at most 1. Because like here, for example, I've got 3 and 3, so they're the same. Here I've got 4 and 3, so 3 and 4, so they're 1 apart, but they can't be 2 apart. And then you can just like construct. I won't bore you with like the construction details, but you can just look at the code. But that's the main idea. My internet's kind of bad at the moment. I don't know why. I mean, I can just talk through the first problem without it loading. The third problem without it loading. I didn't solve this one. I also misread the statement with the constraints, so I was just thinking about it for way too long when I kind of just had the solution sitting there. But so the setup for this problem, I mean, you've probably heard the problem, but you just have an array. Sorry, you have a string. It wasn't an array, but it simplifies to that. So you have a string like this, and you perform reversals on the string in a given with given rules. So you choose some kind of k, and then you reverse. Let's say k is 4 in this case. You reverse this substring, the first k, then the next k, then the next k, overlapping like this. But so you just reverse all these in that order. And you want to choose k such that you get the lexicographically smallest string. And I mean, if you just do this reversal, if you just do this for one of the examples, so it's a DCB EF, then you reverse the middle 4, so you get DE ABC F, and then you reverse the last 4, you get DEF ABC. So you kind of just realize that all this does is it takes the first k minus 1 characters and just moves them to the end of the string. And then depending on the parity, depending on the number of swaps you ended up doing, so the parity of like n minus k plus 1, depending on the parity of that, it might also be reversed. But so since you actually have time for in this problem, the sum of n overall test cases does not exceed 5,000. N squared is fine. So you can just try every k by hand. And as long as you know that this is the rule that's going to happen, you don't have to go through all reversals. You just construct this string, potentially like flip the second half, and then you just compare them all and see which one's best. So that's problem C. And finally, problem D. I mean, none of us got to this one in time, but you're given two squares. This diagram is quite good. You're given two squares in the coordinate system with like integer coordinates, but one of them's rotated 45 degrees like this. And you want to check if they overlap at all. So even by a corner, or, this is also overlapping. Obviously, this is not. This is overlapping. And yeah, I mean, if we roll out templates, there are like geometry libraries, geometry templates that just do this for you. Like this will just be one of the functions. Although I guess it's kind of lucky we don't have them because I don't use those. But yeah, so I was actually short on time here. So I kind of made an assumption and just went with it because I knew otherwise that I wouldn't finish in time, let alone like beat my opponent, just like finish in time. So, obviously if you can check like whether each corner is within the square, is within the other square, and obviously like if this corner is in the other square, then they overlap. But you can also have cases where that isn't the case and they still overlap. So something like this, obviously like these overlap, but wait. No, these obviously like this corner is in this square. Never mind. You can have cases like this where there's no corner inside, but the squares still overlap. But what I was trying to do here is I kind of made the assumption that if you include the centers in your checks, so if I also check whether the center of each square is in the other square, then that would be not only sufficient, but also necessary for the overlaps. So it would be equivalent to check that. So the algorithm I was writing just like goes through all points. The extremely ugly code I was writing goes through all points in this slanted rectangle, in this one, all corners and the center, and checks whether they're inside the other one. And it's easy to check whether they're inside this one because this one's just like parallel to the axes, and it's a rectangle. I mean, it's a square, but more generally, it's a rectangle. So you can just check whether it's like within, whether each of its coordinates are in a specific range. And then I was going to do the same the other way around for the other square. I ran out of time for that, but instead of like doing some weird maths with like lines, you can just rotate the whole image by 45 degrees and just do the same checks as if this blue square was the original square that was in parallel space. And the rotation like introduces a like 1/√2 component because of like the way these vectors like rotate, because you still want like this magnitude to be 1 and whatever. But so it introduces 1/√2, but it introduces it in all of the dimensions, so you can just not introduce that. You can like not multiply that by that, and you'll just get a bigger image, but it like the inclusivity will it'll be the same image in terms of whether points are inside shapes or not. So that's what I was going to do. I haven't actually proved that this is correct, by the way. So the thing I need to prove is that assuming no corners or centers are inside the other square, they definitely don't overlap. And I think that's specifically for the case with like the two squares being 45 degrees apart. And I think that seems reasonable. And why is that? So let's assume, like without loss of generality, these are kind of equivalent. Let's assume that they overlap. Let's assume that for this square, some part of it overlaps within this triangle, because like you can just split the square into four triangles. So let's assume without loss of generality that something in this triangle overlaps with the other square. Well, if something in this triangle overlaps with the other square, and none of the other square's corners are inside this one, that means like the other square's corners have to be how do I show this? I can't actually see a good way of showing this formally, but it seems to be true. I'm not going to show this formally, but it seems to be true. But yeah. Okay. Yeah, that's basically it. This was quite fun. I'm going to check who I'm up against next in the bracket. I wasn't expecting to get this far, so I hadn't really looked at this, but yeah, this is me. So I guess this match will be coming up at some point. Oh. Okay. Let me see if anything's in the chat of note. Otherwise, yeah, that was pretty fun. See you in the next one. Sometime in a few days. Bye.